Welcome back to educator.com, Introduction to C++. Today we're going to be talking about how the computer and the compiler keeps your data in memory. Okay, we need to keep variables and identifiers, which are also called names. We have names for all sorts of different things. In particular, we'll have names for where a particular bit of data is stored. We'll talk about how those identifiers are put into your system, some styles for how you spell your different names, different things. We'll talk about the simple data types today. Later on, we'll talk about more complex data types, but today it's the simple data types. We have literals, numeric literals, like 1, 2, 7.5, character literals like Alvin, or just a single character such as the tab. String literals, which is basically, actually this was a string literal here, this is a series of characters, and variable type declarations. We want to have a particular variable, we want to give it a type. Unlike some languages you may have been exposed to, you might have seen before, C is C++ is a strongly typed language, and once you give a variable a type, it stays in that type. You can't just change it willy-nilly. And how we initialize the variables. All right, now the compiler for C++ requires identifiers to identify various objects, particular variables, structures, objects, etc. Identifiers are names, and a name may contain any combination, almost, of letters, underscore, and digits. You can't put plus signs and minus signs, punctuation, exclamation points. Now, one of the restrictions are the name must begin with a letter or an underscore. So here's some valid identifiers here. We have Billy, have Ice9, we have underscore 42, ice truck, ice cream. These are all valid identifiers. These are not valid identifiers. This is more like a cartoon cursing here. 17, that's a numeric literal, as is -12. For me, it may be for you or for me, but you can't start it with a digit. You and I has got spaces in there. You can't have spaces inside your identifiers. And here's a special character, the @ sign, which makes a very nice email address, but not a good variable. Now, some language, it doesn't matter if you have uppercase or lowercase. In C and C++, the case matters. All these variables are different. You can put Fred equals 1, Fred equals 2, Fred equals 7.3. Now, you confuse people doing that, but the compiler will let you do it. So basically, just keep in mind that your capitalization should be consistent, and don't try to do these kind of fancy tricks because you'll cause heartburn. Now, some identifiers, you can have any combination, but it cannot be a keyword. Certain keywords include int, while, for, bool. There's a long list. And I wouldn't worry about what that list is right now, because you will learn what they are as we go through the class. And if you use something improperly, the compiler will flag it as an error. Now, how do we name an identifier if it's going to have more than one word in it? We've got like ice cream. That's 2 words. Ice cream. Now, there's a couple of schools of thought for how you do that. Some people like to use the underscore. So we've got ice, an underscore, cream. Rocky road. Cookies and cream. See, we've got the underscores here separating the words because this particular variable has some meaning in the system, and it happens to be something with more than one word in it. Another school of thought is capitalize the first letter of each word. So we have ice cream, the first letter of the word cream has been capitalized. Rocky road, cookies and cream. The compiler doesn't care. Use whichever way you want to do. Just keep in mind, you've got humans who have to read the code. So pick a style for your human readers. Stick with it. Stay consistent, because you don't want your humans to look at it and say, what is this guy doing? What's going on here? You want the humans to understand the code that you write. If you're working for a company and they have a particular standard, follow that standard. If it doesn't have a standard, you might want to think about setting one up. But if you see a bunch of code, you're using different standards, you're doing different ways, leave it alone. Don't break the budget. If you happen to have inconsistencies, don't worry about it. Don't fix something that's not broken. So here's some typical styles. Variables starting with a lowercase, a variable such as, for example here, weight equals 200. So we start it with a lowercase variable. We have weight, we have height, we have total amount. It has to be equal to something. You work some calculations to figure out what your total amount is, add all your different amounts are, and keep a variable called total amount. Adjusted price, you add taxes, what have you. Very often you write functions, and you'll start those with a lowercase, and they will be verbs because the function is doing something. So we want to calculate the price, that's a verb. We want to get the next object. We want to display something on the screen. So your variables that contain the data tend to be nouns. Your functions that do something tend to be verbs. Not always, it's just a tendency. When you have classes and types, it's typical to start them with an uppercase letter. So we have an employee class, which defines a class of variables, defines an object for object-oriented programming. Your transactions start with a capital T. Automobiles start with a capital A. Now, you don't necessarily have to do this. In some places, they will also have those with lowercase letters. But these are just some styles that are very typical that you might want to adopt or not adopt. Constants tend to be in all uppercase. So we have pi as a constant. We hope it's never going to change. the maximum number of rows that you're allowed for something, path mask. If you have a file name, it has to be a certain path to get that particular file. You have a maximum number of letters in that path. And these are all things that they're not necessarily defined in the system, but you may define them in your system. And if you have a company standard, use the company standard. If you don't, like I said, you might want to set one up. If it's too much hassle to set one up, just use one for your own code. It's usually a good idea if each programmer on the team adopts the same style, but it's not necessary. It's just different things to think about and discuss with your team members. Now here's a list of simple data types that are available in C and C++. You have your char, your character, which is 1 byte. It's 8 bits, and this is the range because it is a signed number, so it can go from -128 to +127. Now you can declare it to be an unsigned char. That means it can't be negative. And because of that, it's the same number of bits, you can have a larger number. So now instead of going to 128, you can go to 255. You have the same sort of thing with a short. That's 2 bytes. Short int is another way of saying it. Unsigned short int. And here you have the same types of things. You have with 2 bytes, you have a larger range of numbers. When it's unsigned, you have a larger range of positive numbers. Int is 4 bytes. It's 32 bits. This is the range. Keep this in mind for things like you don't want to use an int to store a phone number because you've got, what do we got here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. It's very possible, especially in international phone numbers, to have more than 10 digits. And after a phone number is not a number. It's an identifier for connecting. But that's neither here nor there. But it's just something to keep in mind. I've seen people try to do this and wonder why their program stops working when a certain phone number is entered. You have long, which is also 4 bytes. You would think that would be more, but it's not necessarily more. These are typical. Now, some compilers might say, well, we're going to have 8 bytes for a long integer. It's not necessary. The specification for C and C++ allows a certain amount of latitude for the compiler writers. Basically, they just want char to be less than or equal to short, which is less than or equal to int, which is less than or equal to long. And the int is at least 32 bits. And that's the only hard and fast rule for the sizes of these variables. These variables are typical sizes. We need to declare some variables before we use them. So other languages, you just go ahead and start using variables in the compiler. So, oh, here's a new variable. C++, you need to declare it first. And you need to tell it what type it is. So here we have an integer, number of tries. The syntax is the type goes first, and then your identifier goes next. Here's one. It's a floating point number. It's float and weight. Now, I hope you're already aware of the difference between an integer and a floating point number. An integer is like 1, 2, 58, 902. A weight is defined as a float. It can be 1.2, 3000.3005, whatever. These are floating. The basic rule of thumb, there will be a decimal point in it, and it can float basically in terms of how the number is stored in memory. And commentary is not just a good idea, it's an extremely good idea. Put commentary in your code, especially with variables, especially if you've got a very long variable name that you want to shorten to something in order to keep from having to type forever. It's also good if it's naturally short. So here we have a comment. The user's weight in pounds. Now, your weight is not necessarily in pounds. In England, your weight is measured in stones, very typically. In much of Europe, your weight is measured in kilograms, even though kilograms is actually a measure of mass. We won't quibble over that. Float, height. We have a comment here. The user's height in feet. This is why this commentary is important. Someone comes back later and reads the code, they'll understand what all this is all about. And this is how the comment starts. You've got 2 slashes, and it goes until the end of the line. Another type of comment starts with a slash asterisk, and you can have as much comment, as many lines as you want, and then ends with an asterisk slash. But it's a good idea to sprinkle your code with informative comments. Make sure that they are informative. Don't just tell the story of your life in the comments. Now, one of the things about defining the variable, you can have more than one variable for a given type. So that you have type, your identifier, comma, etc., as many as you want. Float, height, comma, weight, comma, age, and then every line ends with a semicolon. It's still a good idea to have commentary, but in this case, if you're going line, you won't have any room at the end of the line to put one of these end of line comments. So then you have to use your block comment, slash, asterisk, blah, 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 blah. All these variables mean this, and then end it with the slash, asterisk, slash. And you can have a certain amount of suffering of readability because you've got all this text over here, and you don't necessarily have an immediate association between the text of your comment and the variables, which is why I like the one line at a time better. There's things to be said going both ways, but this is my preference. Now, the compiler allocates storage for you. You don't have to worry about where am I going to store this number. You just say, I have a number, is equal to this. The compiler says, okay, fine, I'll find a place in memory and I'll put it there. So the storage is allocated by the type and the array size if there's an array. So int will be 4 bytes, we'll take 4 bytes, and I will put the 4 bytes here. If you have an array of 4 bytes, let's have an array of 10, 10 integers, that's 40 bytes. It's okay, I need to find a block of 40 bytes, and I will put your array of integers there. So, and the compiler keeps track of all that for you. One of the things that was great about C and C++ and other languages before that, you had assembly language, which was very close to machine language, and the programmer had to worry about where am I going to store all this data. Now, you don't have to worry about it. The compiler takes care of it. So the programmer doesn't have to worry about where the data is. The C++ has means where if you need to worry about that, you can, but we're not going to talk about that. Now here's an example. We have int a, float b, char c20. Now remember, this is 4 bytes, this is 4 bytes. Now each char is 1 byte, but this is an array of 20 of them, so it will be 20 bytes, and here's another 4 bytes. Now the compiler may put a first, followed by b, followed by c, and followed by d. The compiler is free to put it anywhere it wants. It may have, I have a block of memory here, I'm going to put all my integers here. So it'll put A there, and then it'll put D right after it. And I've got another block of memory over here, and I'm going to put all my floating points. I got another block of memory, I'm going to put all my character strings. The compiler might do that. It might do D first, followed by C, but yeah, you don't have to worry about it, which is the point of this. You just know that A is going to, I'm going to say A equals 5, and the next time you access it, you say D equals A plus 2. The compiler will say, well, let's go to where I stored A, grab that 5, add 2 to it, that adds up to 7, and put that into D, and then put that 7 where I stored D. Now, when you put some code in here, your code should have an initial variable before you start working with it. A lot of bugs in a lot of applications are because people start using their data without initializing it first. So it would work sometimes because sometimes the data would just accidentally be set to 0. And then something would happen, the application would drop into memory right after some other application. For whatever reason, the variable was not set to 0. They start using the variable and get all kinds of funny results, and they scratch their head, why am I getting funny results? Well, you solve that by making sure that all your variables always have an initial value. And the way you do that, the C style, is you have your type, your name of the variable, and then equals 0. It's just like an assignment statement. You could have A equals 5, or you could say int A equals 5. Now remember, if you change it to something else, you don't have to say int A equals 7. You've already declared it, so you don't do that. So you can have int B equals 5, or you can say int B equals 5 like this. So here's a couple of another initialization example. We have int, the beginning count is set to 0, and then comma, the final count is set to 0, and then semicolon to end that statement. Now there's also a C++ style, which is object-oriented, so you could treat the simple data types as if they were classes. So you have your type, identifier, and then parentheses, put your value in there. So we have int, your credit score, 750 inside parentheses, and of course semicolon ends the line. Your float, your weight is set to 150.3. Your height is 5.5, presumably feet, since that's what we declared it earlier in this class. So it's 150.3 pounds, 5.5 feet. And it's highly recommended to always, whichever one you want to use, again, it could be a company standard, but pick a standard, use it consistently, and try to always make sure that your variables have an initial value before you start processing, so you have a known state before you start working with your data. Now we'll talk a little bit about numeric literals. The numbers are pretty straightforward. You want to say A equals 5. 5 is a numeric literal. Integers. These are some examples of some numeric literals. It's something as opposed to a variable. A is a variable. You could say A equals some other variable plus 1. So now we've changed it. 5 can never change. 1 can never change. That's a literal for putting numbers in there. Here's some floating point numbers for a literal. Here's 0.01. If this was dollars, that would be a penny. Here's 1.23. Again, if that was dollars, that would be $1.23. Here's minus 100.0. They say, well, why am I using a floating point when this actually is a round even number? Well, you don't know. You might want to add 0.01 to that in some variable. You might have B defined to be a floating point, and it's equal to minus 100.0 plus 0.01. Put our semicolon there. So now B is equal to minus 100. Actually, no, what that'll be? That'll be minus 99.99, because this is a positive number being added to a negative number. Now, long types might want to put a modifier on it to let the compiler know this number is supposed to be a long number. And the way you do that is you put the capital L on the end of it. You can put a lower L. I recommend against that because it looks just like a digit 1. That confuses you like all crazy. So always use a capital letter. You can have long floating point numbers. So here's 1.0, which is telling the compiler, I want that to be a double precision floating point number. Allocate as much space as required because of the capital L. Here's one, 3.99 times 10 to the minus 20th is what that E. Oh, I should have talked about that up here. Here you have 3.99 e to the minus 20th. That is scientific notation. Let's talk about that for a second. If we have 3.99 e to the 10, that's 3, and it's multiplied. That's 3 times 10 to the 10th power. So that will be moving this decimal point over 10 times. So that's 399, 1, 2, 3, 4, 5, 6, 7, 8. So if you're used to scientific notation, that's the way you specify it with the letter E. In this particular case, we've got 3.99 e to the minus 20th. So that's moving it the other direction. So that would be 0. Now, I should have made such a large one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then the 3. That's 20 decimal places, and then 9, 9. This is a very small number, which of course with a lot of applications you need small numbers. You cannot do this with an integer, so you need the floating point. Now, one thing to be warned about is do not put commas, dollar signs, or punctuation in your numbers. Here's an example: 10,000 with a comma. That's wrong. Don't do that. You can't even input numbers like that unless you write special code to take the commas out, because the compiler will not handle it. And here's one thing I wanted to show. We have u is an unsigned integer. And here's an example of what I was talking about. This is an unsigned long. That's not the digit 1, but if you look at, here's a 1. This is a lowercase l, and they look almost identical. That's why capital L is the way to go with that. Now we'll have a little discussion about character literals. You can have a single character which can be translated into some encoding scheme, usually ASCII. Sometimes EBCDIC is an old one that IBM invented many, many years ago. Someone might invent a new one, or you could use UTF, whatever else, etc. The only thing I want you to be worried about is the forward and reverse quote that can happen with your word processor. So here's some character literals. Here's a lowercase a surrounded by a single quote, sometimes called an apostrophe. So that's your lowercase a. Here's a space. Here is a null character. The slash is quoting the 0, because otherwise if you just have 0, that's the 0 character. Not the 0 integer, but the 0 character. Putting the slash there makes it a 0 integer stored in a character. And here's what I'm talking about, those quotes. The word processor did auto quotes around this Z. There's the reverse quote on the front, the forward quote on the back, and your C++ compiler will not like those. Now in these PowerPoint slides, most of the time, I've tried to use a regular quote, but in many cases it was just too much hassle. Just went on ahead with let the auto quotes get produced. So just keep in mind that you don't have this type of quote, or the reverse quote, forward quote, the leaning to the left, leaning to all the other various things. That's all a word processor mechanism. Now a character is stored in memory as a 1-byte integer in the ASCII code, usually ASCII. Characters and integers are pretty much interchangeable, except the integer requires more bytes than the character does. So basically, for example, A encodes into 65. So if you look at an ASCII table, you'll see A is 65, 66 will be B, etc., etc., etc. And the reason why you keep that in mind is there are many functions that you will call from the C++ standard library, which will return an int, which will be 4 bytes long, but you're only going to be interested in the 1 byte, which will be the character. So you'll either cast it into a character, or you'll just use it as if it was a character, etc., etc. But this is how you put it inside. Like if you had, for example, define it as a char type, A is equal to quote A, quote, semicolon. Let's make it capital A. So that will store a 65 in this memory position. Now I showed you that /0, which gave you the actual put a 0 in your character. You can also, there's a bunch of characters that you can't see and you can't look at, but they do affect how things display. New line probably being the most common, which is your /n. We'll see a lot of that in the future. There's also /t for a horizontal tab. This is what the number for new line is for 10. It's a line feed. And this is the hexadecimal for it. It's the hexadecimal capital A. Well, not necessarily capital. I just put it capital here. Horizontal tab is decimal 9, which in hexadecimal is 9. Vertical tab is 11. In hexadecimal, that's B. Let's get one that's 2 digits. Your backslash. You want to actually not put, if you put something like this, the backslash quote, says, oh, he wants to put a single quote there, so we'll put a single quote there. But no, I want a backslash. Well, in that case, you have to do backslash, backslash. So that will be a single character backslash. And that in ASCII is 92 in decimal, or 5C in hexadecimal. And there's single quote, there's double quote, and you might want to actually put a specific number that's not necessarily supposed to be interpreted as a character. You actually give it its octal code or its hexadecimal code for whatever that number is supposed to be, if it's going to be in quotes, such as Now that'll give you your new line, although this is the slash n is much more universally recognized, so that's the preferred way to do it. Now, string literals. A string is a string of characters. The C style is actually an array of C chart. So here we have this. There was supposed to be a pointer there. This is a pointer to a string of characters, and here we use the double quote to specify this is a string. This is more than one character. This will get the character H, the character E, the character L, character O, and then it will be terminated by a null character, and that's your /0. That was the actual binary 0 stored in that position. Here we have an array of characters called president name. The array allocates 20 characters, 20 times however much space the type takes. So here we have, is Washington, is a perfectly decent president. So here's an example of how hello was stored, H-E-L-L-O with that terminating character. Washington, W-A-S-H-I-N-G-T-O-N, and the null terminator. And then after that, some compilers will initialize it to 0, other compilers will just leave whatever random memory was there. But here we have 20 characters were allocated in memory and how they were set. So the character string uses, and also the thing to keep in mind, you have your word processor, you've got your automatic quotes where they put the left quote on one side, the right quote on the other side. Your C++ compiler doesn't like those. You want the double quote that's on the keyboard. There's a key that has a double quote and quote on it. You want that particular character, not the magic that your word processor. Generally, when you have a text editor or a specific IDE that's designed for programmers, it won't be a problem. But if you take a word processor output, you might have that problem with word processors. Now, C++ also has a string object, which includes a published interface. It's got a lot of different methods for handling that. And the implementation of that string object is on a need-to-know basis, and you don't need to know. But the C style is very famous. It's been used for many years, and everybody knows how to handle it. But in C++, very often you will need to use the string object because it includes a lot of methods that you can work with. Basically, the literal will be stored C style, and the string object will convert it to a string object inside of the object as necessary. Now, we've got some homework. In your materials that you can download, there is homework to do that you can help practice all this kind of good stuff. I highly recommend you do all the homework. I don't have quiz questions such as, what is the value of this? Is the answer A, B, C? I actually have things for you to do, to put together applications, put together programs, which I think is a much better way to learn things. And don't eat your pencil. It doesn't taste very good. And that's it for today's class on Introduction to C++. Appreciate your attention, and we'll see you next time at educator.com.